Welcome back to the Policy Viz podcast. I'm your host, Jon Schwabish. Thanks for tuning in to the show. On this week's episode of the podcast, I welcome Maarten Boers, scientist who's written a great new book on visualizing data, something I really am interested in, obviously, and I'm sure you are too, having listening to this podcast. Now, why should you read Maarten's book and listen to this podcast in addition to all the other great books that you're reading? I think there are two big things to consider with this book. First, he spends a lot of time talking about table design, and we're going to talk about it in the interview. It's something that doesn't really get a lot of attention in the data visualization library. So from my perspective, it's really Maarten's new book, my book, and Stephen Few's book are really the few books that talk about table design. So that's one thing. If you're interested in better tables, this is the episode for you. The other thing that we talk about a lot is small multiples, or what Maarten calls matrix graphs. So we talk about good styles and designs and ideas and concepts about creating better small multiple charts, which, if you don't know, are exactly what they sound like, a combination of smaller multiple charts. And the last thing that we talk about that is really interesting for me, from my perspective, as someone who's worked in publishing in the academic field, in academic journals, is how the academic publishing doesn't focus on data visualization and how that's been a detriment to the ability to communicate research and scientific findings more effectively. So there's a lot of information and guidance packed into this interview and into Maarten's book. So I hope you'll enjoy this week's episode of the podcast. My interview with Maarten Boers starts right now. Hi, Maarten. Good, well, afternoon your time, morning my time. How are you? Happy New Year. Good to see you.
Hi, good to see you too. Thank you for inviting me to do this interview.
Yeah,
I'm really
this
excited.
is terrific. I'm excited to chat with you. I've got your book, Data Visualization for Biomedical Scientists. We'll talk about how it's not just for biomedical scientists. And there are some unique pieces in your book that you don't find in many other data visualization books. So I'm excited to chat with you. So maybe we can start with your background, and then we just jump right in, talk about the book. The first question I have about the book is, what are the unique challenges with visualizing data that biomedical scientists face? And then I think we can, because the book is definitely broader than just that, but I think we can start there. So kind of two questions for you, just kick the whole thing off.
Yeah, well, I mean, to be really honest, I don't think there are unique challenges to biomedical science. The reason I decided to focus on what is my own field is that there's lots of general data visualization books around, and some of them also address scientific papers and presentations. Um, and in the process of writing my book, I had some feedback from some very notable people in the field, and one of them said, why write another book on data visualization? I mean, look at my book. That's all people need.
Oh, yeah, right. Yeah.
Right? And I was writing this book because even though that book was great, and there are many great books out there, and I referenced them all in my book. It's not like I suddenly invented this field, but I was struggling with what I could not find in those books that were day-to-day issues in the papers I was trying to write, or mostly I was trying to supervise in my fellows, and finding out that there was no guidance at all, and everybody did it wrong, including senior scientists. And nothing was being corrected from the journals. If you look at the journal templates, 99% are simply horrible and could be easily improved. So I started, writing about that and writing to journal editors. And when I was on editorial board, spending time to improve papers and writing guidelines. And, that sort of expanded into something. Then I decided, COVID came along. Let's write a book.
Yeah.
So that's basically how it happened. But I think, and biomedical science is my field, so I know what's wrong in my field. And if I were to say, okay, and by the way, economics or another field, they have poor graphs as well, then I'd really have to go and study those journals to make sure that I wasn't making a fool of myself and people would fall all over me. Oh, you haven't seen me done this and that. I know my
Right.
field. So I thought, if I stick to that, nobody can blame me
Yeah.
for going outside of my comfort zone.
So,
So
but let's
that's
talk about that a little bit because, like, I will tell you in the economics field, like, the graphs are also fairly terrible in most journals. And so you spend there's like this section right at the end that's kind of tucked away, but it's kind of like my favorite part because it talks about this peer review process that nobody talks about. Um, and I guess I'm not sure what my question is other than why do you think peer reviewed journals haven't tapped into what we know is data visualization as a popular means to communicate research and data?
because nobody feels enough of an expert
Hmm.
to comment on it.
Hmm.
And so it's from the junior to all the way to the senior level that nobody knows how to do it.
Yeah.
And so I was interested in data visualization right from the very beginning of my scientific career or before. So
Hmm.
I always spent a lot of time, doing stuff. But nobody of my supervisors would ever comment on that part.
Right.
And if you made a table, um, well, you just made a table and nobody said, gee, why don't you, why is the order of your categories like this? Or why have you ordered your numbers in this way? And why is this table so terrible to read? It was sort of a natural phenomenon that tables and graphs would magically appear.
Yeah. Yeah.
And then right from the first version, they would go all the way into the published paper.
Right.
And unfortunately, that is either still the case or journals have caught up and put in some guidelines that make tables and graphs worse
Right. So they've built these
rather than better.
templates. Right. They've built these templates that are not built by, I mean, I'm sure well intentioned, but not people who may have expertise in how to do these well.
Or and I mean, the most recent version of this is that the bigger journals have put little software machines in place
Mm.
where once you are past the acceptance stage, you go into the proof, you get your proof, but the proof is no longer a PDF, but it's actually a web page where you
Hmm.
can, correct your paper. And the web page has a little table machine in there that
Ah,
does not allow you to format the table properly,
right.
or it makes it so difficult that
Right.
everybody gives up.
Right. So there's a revenue stream problem in academic publishing, right? Like the first paper I wrote, I remember the first paper that I co-authored back in the day. The journal helped make all the graphics. They had all the editors. I mean, there was a team, and now you're on your own. It's like,
Exactly,
yeah.
exactly,
Um, and
exactly.
and do you think? I mean, this is looking ahead, but do you think that maybe some of this artificial intelligence tools and as the data viz tools maybe start to develop and get better, that will be helpful, or do you think we're just going to be spinning our wheels and you
Well,
know
yeah, well, if you say AI, AI needs to be trained. And if
yeah,
AI is going to be trained with the current body of literature, they
yeah,
will
right,
ingrain
right,
the horrible practice that we
right,
have now.
right,
So,
yeah, that's right, that's right,
I
yeah.
hadn't even thought of that, but you've given me a new nightmare
Oh
to
no.
contemplate. That's not going to really help. I mean,
Yeah.
it, the software has improved immensely. So
Right.
there's much better tools that you can use today than there were when I started out. I mean, when I started out, we didn't have computers. I mean, I'm that old.
Punch cards.
And actually, I started before we had punch
Four
cards.
punch cards. Okay.
So my first scientific article was drawn by a scientific artist
Oh wow.
who had like the architects have.
Yeah,
So
yeah,
they
the big
big pieces of paper,
drafting
and then
board. Yeah.
they would have paper, and then they would have sets of dotted and dashed lines
Oh wow.
on paper, and they would put it on the line, and then they would scratch the ink onto the. Well, that was pure art.
Yeah.
So that,
Yeah.
and I remember dreaming of a computer program when the first Mac started, when the the first Mac came on the market. I dreamt of a program that would do things.
We'll do it. Yeah.
Uh, and when that program appeared, it isn't around anymore, so I can safely name it without sponsoring anybody. Cricket Graph.
Oh,
When
wow.
when that program came along, I bought my first Mac
Ah.
because I had dreamed of that program. You click on an axis and it opens and you can change the scale, that sort of thing.
Yeah.
Well,
Yeah.
that's routine now. It
Yeah.
wasn't around. So
Right.
I've seen it all come, and I mean now there's such good programs, and some of the programs are invented by people who know about graphs.
Yeah.
So the default is already half or three quarters good, which means the errors, if you just keep on the default, you already have a pretty good
Right.
starting point. And many people don't get past the default, as you know.
Yeah. Right. Right. They
When
just
when,
drop
when
in, click insert.
Microsoft changed their standard font, everybody uses that font because
Mm-hmm.
nobody ever changes a font.
Right.
And it's with graphs and with tables, it's the same way. You have one template. Oh, that's the way to do it. Okay, fine.
Right.
Don't think about
Right.
it. So anyway,
So you've mentioned a couple times tables, and the
yeah,
first chapter after the introduction, the first chapter in your book is on table design. And by my count, there are only 3 data visualization books that spend any significant time talking about tables.
yeah,
Your book, my book, and Stephen Few's book. And those are the only 3 that I'm aware of that spend any
exactly.
significant time. And I'm curious. I guess my curiosity really stemmed why you decided to do tables at the very beginning of the
Um, well, I was going to do a book on graphs,
book.
and
Right.
then I thought, yeah, but I need to do tables first
Yeah.
because
Yeah.
tables, in a way, um, are simpler.
Mm-hmm.
Although making a good table is pretty difficult, but
Mm-hmm.
tables are simpler because you don't have all these directions you can go in,
Yeah.
and they are sort of the basic staple of science.
Yeah.
That's not graphs, it's tables.
Yeah.
And um, exactly like you say, nobody writes about them. So I was highly inspired when I didn't have your book then. I just had Stephen Few's book, and I thought,
Mm-hmm.
here's a guy who writes about table, and it's really, I mean, his table chapter is really very good.
Yeah.
So uh, like with all things, do I need to add to that? Yes, because Stephen does not address the issues I have in my field with tables, and extensively described in the chapter where you have, and I'm moving away from that, but that's what you see very commonly. You have multiple numbers
Mm-hmm.
within one cell that are, unclearly separated. So you have these number blurbs that almost become words inside a cell. And then
Yeah.
on the next line, you have the same blurb, but slightly differently. And,
Mm-hmm.
within 4 lines, your table is a total mess. So
Yeah. Yeah.
there were quite a number of things that Stephen Few didn't have to focus on because his tables were basically about business and sales
Right.
and housing and whatever. So it's
Right.
sort of one category, which is either dollars or bricks or whatever. And we
Yes.
have all
Right.
these multi-item tables with different things. So
Yeah.
there's highly specific things that I was struggling with before I wrote the chapter, and I had sort of found some solutions for, which were universally rejected by journals if I submit it. They say, yeah, but this is not
Uh.
standard. Yeah, but your standard is.
I mean, it's so interesting. Like they have their own publishing platform, whatever tools they use,
Yeah,
and it's like that's it. And if it
yeah.
doesn't fit in that little box, then you're
Well, it's worse than that. I think most of the journals have one template which looks like a format, um,
Mm-hmm.
but what they do is they just pour your numbers in the cells and then
Yeah.
forget about it.
Right.
There's some good journals that make very nice tables, but usually it's just, oh, You're submitting a table. Okay, here's our matrix. Pour it in. There you go. This is our
Yeah.
format. This is how we
Right.
always do it. So
Right.
there's no thinking behind it. It's just production.
Right. What would your top recommendations be for people when it comes to making good tables?
I can name only one.
Okay.
Only one,
Love it.
because I have a lot of one.
Yeah. But one would be good. Yeah.
I think the first recommendation would be proper alignment.
Yeah.
It's about
Yeah.
categories and numbers, and if your numbers are not properly aligned, they're difficult to read.
Yeah. It is fascinating to me when I see this. I'm sure, I mean, science is science. So they have, like you said, you have multiple things in a cell. You've got the, coefficient and a standard error with stars and parentheses around it. And it is shocking to me how the numbers are not aligned. And it is just objectively difficult to read. I don't think we need any sort of like real fundamental study to prove that point. It is just harder to read.
Exactly. So
Yeah.
and it's so basic, and it is fairly easy to correct. I mean, there's some
Yeah.
issues, shall we do it this way, that way? But it's not like, oh my God, how am I going to solve this problem? It's just
Yeah.
saying this is how you do it and implementing it. I think the other thing about tables is to communicate to people that tables are actually sort of like very simple graphs. So you
Yeah.
have to think about the ordering of the information in your table, which
Right.
which I term after one of the other giants, telling a story. So
Mhm.
it's not like you make a table and you order your categories by alphabet or by the order in your database
Mhm.
or by random.
Yeah.
But what do you
Whatever
what do you
your code says the variable name is. Yeah.
usually things you find important are going to be at the top of the table.
Yeah. Yeah.
So don't let
Yeah.
me scroll through 18 rows of noise before
Right.
we hit on the thing you wanted to show me in the first place. So those
Yeah.
those are,
No, I
it's
think, yeah.
more than one. That would be the two things, and then there's all the other stuff. Because as you rightly noted in the prep for this interview, I think that the tables chapter is actually the longest of the whole book.
Well, it is interesting because Stephen's chapter on tables, I don't remember but exactly where, but it's somewhere in the middle of the book. The chapter I wrote on tables is at the end of my book. And I found it interesting that it was at the beginning of this book. But when I think about, at least in economics, and I'm guessing it's similar in your field, if I think about picking up any journal and just going page by page and counting graphs versus tables, I'm sure there are more tables
Yeah.
than graphs in any random journal that I
Yeah, and,
select.
and
And
and in every paper there's a table one, and it always comes before any graph, and
yeah,
gives you the baseline data. So it's sort of
right,
really really basic. Yeah.
yeah. The other interesting piece of the book is you have an entire chapter dedicated to what you call matrix graphs. Other people call it small multiples, trellises, panel chart. I mean, whatever,
Yeah.
right? But um, so again, I'm curious about the decision to write an entire chapter about it. I think I'm not saying I disagree with it. I actually agree with it that it deserves it's one of my pillars of good data visualization is think small multiples and see where you go. So again, what was your thinking behind a whole chapter dedicated to small multiples? And then we could talk about what your top recommendation would be when people are creating
Okay.
tables.
So that chapter has two parts.
Mm-hmm.
The sort of the basic part, the basic principles of small multiples, which covers topics like trying to harmonize your axes so that you can do away with a lot of labeling, and trying to again get the order right for the message you have in your data, whether it
Mm-hmm.
be we like to compare horizontally rather than vertically. So if your main comparison is horizontal, they should be like this, all that sort of stuff,
Mm-hmm.
which goes for uh, all of those what I call matrix graphs. But the real story is the second part, And
Hmm.
the second part is my effort to make a good a matrix graph for basic scientists. So in
Hmm.
my field, basic scientists are the people in the labs. Well, they call themselves usually translational because they want people to feel that they're connected to the bedside. But they do stuff with cells and with DNA and with experimental animals and what have you. Um,
Right.
and within my field, that is a really closed shop of
Hmm.
people who have their own methods of doing research. And if you're not in the in crowd, you usually don't
Hmm.
understand anything of what's going on. And that's because they
Hmm.
have their own codes, they have their own abbreviations, they have their own way of doing things, they have their own way of doing statistical analysis. And I'm, sort of a
Right.
statistician as well, uh, doing a lot of things that in the rest of the world is found to be quite objectionable and not really very right, like doing
Mm.
experiments with very, very small sample sizes and then
Right.
doing parametric statistics to see differences, significant differences, and then doing multiple tests. And I can go on and on. So there's a lot of things in methodology, in uh, my type of methodology, which is not the lab mechanistic methodology, but really statistics, how
Yeah.
to set up your experiment, how to do controls, and all that sort of thing,
Hmm.
um, which is um, well, difficult to understand and usually not the way I would recommend. But the other side of it is they do a lot of, so they have this theory of, whatever, agent A blocks the production of some sort of stuff that you need or not need
Hmm.
from the raw compound, and we're going to prove that that is the fact, and also that it has a biologic effect that is relevant. And so,
Hmm.
so they have this system where they say, okay, let's first look in the genes whether this is happening,
Yeah.
and then let's look at the gene expression, and then let's
Hmm.
look at whether the cells who have that gene expression are actually in the place where they should be doing the work or not. And then if
Hmm.
we have that, then let's look at, in whole lab animals, and let's see whether the agent that is needed for that process is actually being blocked or not. So they have a lot of ways to buttress their theory, which is really very cool.
Right.
In human experiments, we have this drug and we put it in a human and
Hmm.
see, what happens to the human, and we have to infer all those steps in between. So
Yeah.
their, if you want, statistical methodology, I think, is very poor, but their biological methodology is very, very advanced, very
Yeah.
precise, very elegant, and they always have, 3 or 4 ways of proving their point. Say, we start
Yeah.
here and there and there and there, and that's why this is true. So really good stuff, beautiful science. And I always thought when
Yeah.
I saw these horrible matrices that they produce, because they have, like, in an 8-minute presentation, they will have 20 slides, and all those slides are small multiples of at least 16 graphs with unreadable letters
Yeah.
with
Right.
no explanation.
Right.
And they'll say, so
Yeah.
here you see that A was blocked by B. And by the way, whoop, next slide, B was blocked by C, another 20
Right.
graphs. So it was like, oh my God, I can't. So I thought, it may just be that I'm too stupid to understand this stuff. And all the rest of these basic science people, they understand and they're happy with these slides, just me being stupid. So I just said, okay,
Yeah.
I don't understand this graph. And I had a colleague, I work in a university department with a lot of basic scientists. And there was a very nice presentation from one of his PhD students. And I saw from the slides, okay, here's someone who's, sort of interested in trying to convey what's going on to me who is not in the lab. So that was the starting point. And I
Hmm.
said, look, I saw this presentation. It's nice. I understood about 25% of it. I want to understand
Hmm.
100%, and I want to see your
Yeah.
graphs, and I want to see whether I can improve it
Hmm.
after understanding so that it's better. They said, okay.
Yeah.
So, well, it was a bit of to and fro before I had the data and I had the graphs and so I started building this. I think I wasn't working full time. I think it cost me 3 months
Oh
to
wow.
understand the science, really on
Oh
the
yeah.
detail level. And again,
Yeah.
the science is not really very difficult. It's just understanding what's going on in the nucleus with that cytokine and that stuff and what is being activated and repressed.
Sure.
But you have to know what kind of abbreviations they're using. Are they useful?
Mm-hmm.
And then you find
Yeah.
out they always do the same experiment. It's one generic experiment, and they do that in different settings over and over and over
Right.
again.
Over and
It's
over
like
again,
this.
right?
Okay, I have a negative control. Yeah,
Mm-hmm.
it's normal saline or unstimulated cells or wild type baby calves or whatever. It's this. Okay, let's
Yeah.
see what happens. That is my zero condition.
Yeah.
And then I have my positive control, which is
Mm-hmm.
um, let's inject this baby calf with something which will turn all the white blood cells on. We know it does.
Yeah.
So,
Right.
okay, in our system, let's see what happens. And we have, all the leukocyte counts going up or all the interleukins being activated, whatever. So that's my positive control. Okay,
Mm-hmm.
now let's put in the agent we think is going to do something in this system. Let's see
Right.
what happens in this leukocyte
Yeah.
count or whatever the system is I'm using to measure.
Yeah.
Okay, we have that. Okay, now let's see what happens if I put in a blocking agent without my stimulus. Nothing happens because nothing's being
Mm-hmm.
stimulated. Now let's put them in
Yeah.
together. Is it really blocking? Yeah, because the original
Yeah.
is going down by 50%. Okay,
Right.
so this is blocking that. Okay, good. Next experiment. Let's try the same thing in another setup with different readouts. Is it happening there too? Is
Yeah.
it happening there too? Is it happening there too? And then they cycle through this because once they've shown this to be a blocking agent, they're going to see, okay, if I block it and now I stimulate something else, what will be the effect
Mm-hmm.
downstream? And it goes on and on.
Right
But the
downstream.
basic experiment is always positive control, negative control, action, blocking. So those are the
Right.
generic labels. So
Yeah.
why
Yeah.
would I need to read 16 graphs with 𝐓𝐷𝐵𝐾25 and then I have to go down
Right.
to the footnote, which is half a page long, and
Right.
halfway it
Right.
says stimulates um, ABCLL50X, which is
Yeah. Yeah. Yeah.
the readout system that I'm using in this little panel.
Right.
Anyway, I'm using a
Right.
lot of words, but that chapter
No,
cost
no,
me
no,
three
but
months to make. And
yeah.
in the end, well, you've seen it in the book. I hope you said, okay, from the original, this is quite an improvement because I sort of can see what they're doing with little text saying, in this experiment, we showed blah, 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 but not that. And then here, this was
Right.
stimulated, and the labels, the text and the labels are as generic as possible with as little abbreviations as necessary. And then sort of walks you down that path of little multiples
That
so
path.
that at
Yeah.
the end,
Right.
you have the story. And
Yeah. It's kind of like a little
yeah,
comic
it's a
book or a
comic book.
comic strip.
Exactly.
Yeah.
That's the word.
But it's interesting. Your story of that. What's interesting about it is that your focus is not um, so much on should this axis be this width and should the grid lines be this color and should the line be such and such. It's interesting to hear you talk about it because the focus of that story was on making the labels and the language accessible to
Exactly.
people. um, and it is interesting to me because this is one of the things that I talk about with people, that it's about the titling and the labels and the annotation, because a graph, whether a graph is beautiful or not, is a lot in the eye of the beholder, right? You like blue, I like green, whatever. But it's being able to tell people what's going on in the graph with the
Yeah.
words. And I guess I'll say one last thing, and then I'll let you just respond. That I think you've heard this too, where people say, "Oh, you should just be able to look at a graph and get it right away." And I don't think that's
Nope.
true, because you need words.
No, well, there are rare instances. I mean, they say, one picture is worth 1,000 words. Okay, but usually the graphs that are immediately obvious are those situations where I say, did you really need a graph for this? So,
Yeah,
if
that's
I
right.
show
Yeah.
you a graph with a mean length of men versus women, and you see a bar with
Mhm.
men being higher than women, you
Yeah.
say, okay, so men are bigger, larger than
Right.
women. Then I say, okay, you could have said that in one sentence, right? So did you really
Right.
need
Yeah.
this bar?
Yeah. It's
This
two
is what
numbers, right? Yeah.
pharma used to do. They've moved on from that, I have to say, but they used to show you these graphs, before, after, with big bars. So,
Hmm.
oh, right. Oh,
Right.
yeah. So, oh, now I see it in a graph. Oh, man. No,
Right.
I think, and there's also this other thing of, um, I think, more traditional scientific views that you should not impose on the reader your interpretation of the data. I'm just showing you the data, and then you can make your own interpretation. And I'm not going to bias you by telling you, well, that's all nonsense.
Yeah.
In current
Yeah.
times, people spend maybe 2 or 3 minutes on an abstract before moving on to the next. And if you want to hit them, you
Yeah.
hit them between the eyes. So the graph and the caption and everything is telling you that message again and again and again. So your caption should not read, here's the results of my experiments. I mean, that's not going to help. It's going to say,
Yeah.
this
Right.
clearly shows that A is blocking B.
Yeah. I find this fascinating, and it happens in scientific publishing all the time, where people say, "Oh, I can't tell you what the result is in the graph." But if you go to the text that they write, the text will tell you exactly what the
Exactly.
argument is. But like when you look at the graph, it's like it's just purely descriptive. And I never understood that disconnect between what I write in the text versus what I write in and around the graph. Like why
Well, yeah, I
don't
mean, the
they should
same
be together?
discussion around what one calls declarative titles of papers. So
Mhm.
many
Mhm.
journals will not allow you to say uh, a, a, a randomized trial showing drug A is good for patients with B. No, 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 no,
Right.
no. You have to say a
Right.
randomized trial of the effect of A in patients with B.
Yeah.
In a
But in
text,
the text,
oh.
it'll tell you that first piece. It's just so frustrating to me, and
But
I just don't understand
I
it.
want to come back to what
Yeah.
you said earlier, because it
Yeah.
is really two things. I think it's sort of those two things labeled. I think John Cleveland. You know of John Cleveland? It's an old book, but he was also one of the pioneers. Yeah, Bill
William
Cleveland. Yeah,
Cleveland. Bill
William.
Cleveland.
Yeah, yeah.
Yeah, 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 yeah,
Together
yeah. Yeah.
with Tuft, those were the two,
Yep.
pioneers in the field, the giants that we still worship every day. But I think Bill Cleveland said, "Clear vision and clear understanding," and those two are,
Mhm.
you need them both, and they're not completely independent. But first, you think, okay, what's the main message here? And how I'm going to tell this story. That is the basic. And that would be maybe your
Mhm.
storyboard of your multiple panels saying, I want to show first this experiment and that experiment and that these three together lead to a conclusion which I can use in my next set of experiments, etc., etc. So that is,
Mhm.
if that's not there, if the order there is wrong, then you're immediately lost. But then
Yeah.
then the clear vision comes in, with not only clear labels, but also consistent labels and color
Mhm.
coding and cues in the symbols that you use and the thinness of the axis versus the thickness of the series lines, and always
Mhm.
making your experimental condition slightly more prominent than your control, by either by color or by hue or what have you. And that is the technique of clear vision. It's driven by the story,
Yeah.
but you want, I mean, it's as simple as this happens all the time. So you have this order of, A, then B, then C, and then you have a graph where the order is C, B, A. Like, immediately your brain is, hey,
Yeah.
what was first here?
Right.
And that's usually
Right.
the
Yeah.
programs that
Yeah.
do that, right? They have a tendency
Right.
to
Yeah.
give
Yeah.
you the
Yeah.
wrong
There's some
order.
default built in.
So
Yeah.
all these things is
Right. Yeah.
design, and like in tables, ordering
Yeah.
is design. It sort of fits together, and you need to go back and say, okay,
Yeah.
now I fiddled around with my labels, but is the story still clear? Oh no, because here I used another label because it fit better, or because it was more appropriate in this graph. But given the story, perhaps I should change it to the other label, because then the consistency is maintained. Or I can't, but then I thought about it.
Yeah. Right. I wanted to ask you one last question on the small multiples. So some of the examples in the book have, say, an odd number of graphs. But the way at least some of the examples are is, you might have, let's just say, two squares next to each other and then a rectangle below it that kind of spans across. What would you recommend to people if they have small multiples, but they have an odd number? So they have 1, 2, 3, and they have this blank area, right? That's kind of left over. What do you recommend people do with that blank area?
That's a difficult question. Uh, Also, because usually you're not the one making the page layout. So
Yes, that's true. Right.
any form you produce will be handled or mishandled by someone in the production process, turning it into something
Yeah,
different.
that's true.
I remember with the tables article that I wrote, that they got the layout so wrong that I ended up, printing the proof, cutting it into pieces, putting the layout together, and then making photographs that say, I want it in this order. So if you have these three
Right.
panels, they could either make a big white area, or they could just fill it up with text, in which case maybe it doesn't matter, or they put the caption there, which, if it's big enough, fits coolly inside. Then you have to, place your, I would say, then you have a row on top. If I do it in mirror image, and I would put the third one on the right side, and then I put the caption on the left below the first. Well, that sort of thing. If they allow you to fiddle around, that's fine. I don't think you need to fill up a square space with a stretch graph, just because then you'll have the block filled.
Yeah,
But
kind of forms a square.
it does
Yeah.
remind me to say that it's really important that you think about the limitations of the journal page, whether it be electronic or paper. It isn't really helpful if you make graphs that fill 1.5 column, where it has 2 columns, because either they'll blow it up,
Yeah.
which would be nice, or they'll make it smaller, and then everything becomes unreadable. So you have to think in advance. Okay, what do I want for this figure? Can it be in 1 column? Can it be in 2? Or should it be a full page? And if so, should it be rotated, which is usually not good for figures, because people read upright, etc., etc. So that kind of thing.
Yeah. No, but that's a good point, and it is true that a lot of journals don't tell you that until the very end, or they never tell you that, and they just say this is how it's going to be.
And most authors are so thrilled that their paper is finally accepted. They don't want to be difficult. Where the reality is, the science editor is usually on your side and is just as exasperated with the production process as you are, but is out of the loop. So the moment it goes into production, you're dealing with technicians who may or may not be helpful. So it's perfectly fine just to say, sorry, this proof is not okay because this and that. And then I've had proofs come back 4 times. But then, of course, I'm a cranky old man.
Yeah.
So if you're a junior fellow, that might be a little more difficult.
It's different, yeah. Well, on that note, so the book is Data Visualization for Biomedical Scientists, Creating Tables and Graphs That Work. Maarten, where can folks find you if they have questions or they want to bring you in to talk? Where's the
Well, I
best
think
way
it
to find you?
best were if you just were to project the slides I sent you with my personal details, also um, um, the link to the book if they want to buy it. It's QR codes. And I have to say, I'm actually next week I'm going to be in Canada, in Toronto, to give a data viz course, which is a half day
Great.
affair with some prep work, uh, and that's really a lot of work to do. So I do
Yeah.
travel. And I don't organize these courses myself. Mostly I just tell people, you want me to give that course, okay, then I'll come over, and this is what you need to
Right.
do. So I'm
Sounds great.
yeah.
Yeah, that's great. Well, I'll put links to the book and to your classes site, and folks can get in touch. So, Maarten, thanks so much for coming on the show.
Yeah,
Really appreciate it. It was a
thanks.
great conversation. Thanks for tuning in to this week's episode of the show. I hope you enjoyed that. I hope you will check out Maarten's book. I've put links to his website and all the things that we talked about on the show notes at policyviz.com. And you can check out other resources, other tutorials, and other things around the world of data and data visualization at policyviz.com. Thanks so much for listening. Until next time, this has been the PolicyViz Podcast.